Okay, good afternoon, everybody. This is a joint presentation from myself and Paweł Rubach from Orange, Poland. So, the outline of my presentation, I will give you the context and objectives. I will focus on the, give you an overview of the architecture of our platform. Then I will focus on the CME DMTF IAS API, that is the unified API that we have adopted in the context of our project. Then I will give the floor to my colleague that will detail how we manage placement in a multi-cloud context and some concluding remarks. So multi-cloud management is a very hot topic that seems to draw a lot of attention recently. Typical use cases for multi-cloud are well known. It could be the ability to burst from a private cloud to a public cloud. It could be the ability to satisfy some application-specific constraints in terms of location, in terms of cost, in terms of performance. And of course, multi-cloud is an enabler to achieve disaster recovery, high availability, business continuity. On the other hand, multi-cloud management is purpose is also to achieve interoperability. In the current landscape of cloud providers, each having its own proprietary API, its own resource model, its own virtualization technology with its own virtual machine image format, there's a clear need to hide this heterogeneity and to provide an abstraction on top of all these providers. So, in a nutshell, what is Sirocco? Sirocco is a multi-cloud management platform, or maybe yet another multi-cloud management platform. So the key principle of this platform is to provide a single unified access point to access multiple cloud providers, whether they be private or public, and whatever the technology. This access point is programmatic, so we have chosen the MTF CME API as the unified API to access our platform. I will get back to that in the coming slides. And a key feature of our platform is that we want it to be as extensible and open as possible, with a clear separation between mechanisms and policies, and the ability to make it scalable and open in terms of various, to fit the requirements of specific environments within an enterprise, at the edge of an enterprise, for hybrid or private cloud and so on. So in just one slide, what the Sirocco architecture looks like. If you start at the top, the user-facing interfaces, so is the API, the CME API from the MTF. One thing not mentioned in this slide that we provide also support for the OVF package format from the MTF to package application and to manage the life cycle of applications. At the bottom, you have the ability to plug in some connectors to provide connectivity to a specific cloud provider. For example, OpenStack, VMware, vCloud Director, or Amazon EC2. And the heart of the Sirocco middleware is an orchestrator that deals with the various functional building blocks of our platform, user management, all things related to authentication, authorization, multi-tenancy, of course, resource provisioning and lifecycle management, image management with the ability to handle what we call multi-cloud images that can be projected to a specific cloud providers on a per need basis, and aggregate monitoring and metering. Another building block is the provider and the placement management, and I will give the floor to my colleague that will detail this functionality.
Good afternoon. So the question I'm asking myself is, how do we choose the provider? How do we actually choose whether we have multiple data centers within one cloud provider at different locations, or if we have different cloud provider offers in generally? So when does it happen? Well, first of all, we can have these different data centers within one cloud provider, such as Amazon offers different data centers, for example. And they can also offer different services. This is also important. In some cases, you may specifically want a certain location. Another reason could be, for example, load balancing, in case you want to have for example, deploy your application near active users, or in case you want to have a disaster recovery scenario where you want to have multiple copies deployed at different locations that are geographically distant, or in case we can also measure this distance in terms of network latency, bandwidth, etc. Although this is still a bit picky, it's not going to be probably implemented very soon, but we do prepare for that. On the other hand side, we also have to take into account the fact that we are basically implementing this for a cloud broker, and this cloud broker is supposed to make money on that, so maximize revenue by supplying the best for the customer, and at the same time making money on the difference between prices. So let me show you an example. It's of course a very simple example of a request with 4 CPUs, 6 to 8 gigs of memory, and 40 to 100 gigs of a disk. And now the question is, which of these cloud providers and which of their offers satisfy this use case? Well, in this case, we have 3 offers, and then the question, in fact, is, this can be done very quickly, but then the next question is, how do we actually choose the right one? So, of course, without extra soft constraints such as price or maybe some other things like location, etc., we can't really make a good decision. But that's what we. Of course, in a real use case, you'll have many more constraints, and or else you can simply make use of one of your strategies, depending on the cloud broker's policy. So, to support that, we want to have a flexible and extensible architecture. The point is, we want to be the goals may be evolving, the constraints as well, the offers of cloud providers. Everything may change, but the broker has to be updated with these both the data as well as some policies. For example, do we want to offer the client the least expensive offer we have, or somehow the best offer we can give him? There are many different policies you may imagine, and we want to have an architecture that will provide us with the possibility of quickly changing these policies. Therefore, we designed this architecture. It's, without going into many details, we have on the left-hand side, we have the provider manager, which is the part that's basically dealing with data regarding the offers that we can choose from. And then the right-hand side is the actual decision-making framework with a rules engine and a solver that makes the decision based on some constraints and policies. So it's still. The research is going on, and the implementation has only started recently. But we also already have extended the CME model with things like matching by capabilities, including bundles. So we can have, for example, packages of offers such as the ones you've seen in the table. Matching by locations, including network distance and some more sophisticated matching, and of course the placement requests, decisions, all that's needed to do the placement. The current POC is being developed. It's running, but it's quite very simplified at the moment.
Okay. Now just to conclude, one last slide. What are the next steps? Currently, we have an alpha version of Sirocco available. We plan by the mid-2013 to complete the implementation of the CIMI, the MTF API. One work still in progress is to integrate third-party image forges and factories, whether they be proprietary like UShareSoft or open source. We are also some works under progress to integrate what we call an application lifecycle manager that will accept as input OVF packages to model multi-component applications. And in terms of support of specific cloud providers, we put the focus currently on OpenStack, vCloud Director, and Amazon EC2. But we have yet to complete the mapping, in particular the network mapping, the mapping of the CIMI model to the underlying models of these providers. And in the area of placement that Pawel just presented, we have yet to enhance the matching roles and to make the system more dynamic with the ability to change rules on a dynamic basis, and a more research-oriented aspect is also to be able to provide to implement some feedback mechanisms that is, the placement intelligence can learn from previous decisions to make its current decisions. Okay, that's the end of my presentation.